Welcome to episode 10 of live.withcode.uk. This is half term week, so ever so slightly different this week. First of all, thank you to everyone who took part last week. Particularly well done to Michael from All Saints. You're a competition winner this week, so you'll win some live.withcode.uk headphones and a certificate. This week it's slightly different because the winner of this week's competition will get a microbit. You voted for, and thank you for those people who voted. This week we'll cover animation, and we're going to use a microbit simulator. So you don't need an actual BBC microbit for this, but if you win the competition, you can get one and run your code on that as well. So what does that mean? The code that we'll work through together, we'll choose a random image to put on its little display. So a microbit is a tiny little computer that has 25 pixels, so 5 across and 5 down, and each pixel is just an LED that can be, you can change the brightness of. And it's got 2 buttons, an accelerometer, a compass, all sorts of other digital stuff inside that you can play around with. But the code that we'll write, when you press one of the buttons, a little animation will appear on the screen, and you can decide what that animation is, and it will choose a random picture to go on the screen. The point of today's episode is to get you to think about how animations are just created out of images displayed quickly onto the screen. So let's get started. We're going to, it's live coding, remember, so you'll see all of the mistakes that I make, and I'll try and invite you into the thought processes behind the code. We're going to need 2 modules today. We need the random module, and we also want to import the microbit module. Microbit import star. Notice there's 2 ways of importing stuff in Python. There's import and from, and then the name of the module, import everything. The first way means that if you ever need to access something from the random module, you have to do random dot first. The other way imports everything from that module into what's called the global namespace. So you don't have to do something like microbit dot display. You can just write display. They're both useful for different things, but we're going to use both today. So when we have imported the microbit module and we run the code, Control Enter, you see a little microbit simulator on here. Microbit is just a little bit smaller than a credit card. It's got a 5 by 5 pixel display, just LEDs in red. It's got 2 buttons on the front, loads of pins that you can connect to stuff, accelerometer, compass, all that kind of gadgetry that you can connect to. They're really fun devices. But because there's so few pixels on it, they're great to use for making really simple animations. And you can also run Python code on them. So let's get started. If we want to display something on the screen, the simplest way to do it is display.scroll or display.show, and then you can put a message in there and it will just scroll the text across the 5 by 5 pixel display. Or display.show does the same sort of thing, but instead of scrolling it, it's just one picture, one image after another. So if you don't want to display letters, you can also have certain predefined images. So image.happy will be a happy face, or image.sad will be a sad face. And if you display more than one of them, you'll get yourself an animation. But the problem is your Python code runs so quickly that you won't see the first image. Sad is there for such a short amount of time, which is nice, become happy so quickly, all of the bad memories have disappeared. So we need to sleep for, let's do half a second, 500 milliseconds, and then it's there for half a second, and then we replace on to the next one. So an animation is just a frame, an image, displayed for a short amount of time, and then the next frame. So I would like us to be able to create our own image. So if we create our own image like this, we can switch all the pixels on. So 9 is the maximum brightness, and there's 5 pixels going across. Then we go on to the next line, and we're going to do 1, 2, 3, 4, 5. The next line, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just get rid of these. We've only got one image displayed. So we've switched on all of the pixels. If we want to switch them all off, we just replace the 9s with 0s, and you can see I've only done that for the first line. So if I wanted to turn the last pixel off, it would be the last row and the last column of that last row down here. So you can experiment and do any picture that you like. So let's go to switching them all off. 1, 2, 3, 4, 5. So I'm just double clicking to select a word. 3, 4, 5. And then if you wanted a smiley face, this would be the second row down and the second column across. So second row down, second column across, that one here. And then on the same row, we could put a pixel on over here. And if we want just a line for a particularly unimpressed face, let's do it along this second from bottom row. So let's say 9, 9, 9. There we go, not particularly impressed. You can also vary the brightness. So if you wanted these pixels to be dim but still there, you can replace them with a number between 0 and 9. And it will just, actually on the microbit, it will switch them on and off very quickly, but to the human eye it will look like they're dimmed a little bit. Okay, so what we want to do is choose a picture at random and then go for a little animation and then go back to our random picture. So rather than just doing, let's go back to switching them all off, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Rather than just having one frame, let's instead store that into a list. So let's say animation equals, and then we can show that animation here. Doesn't do anything yet because all the pixels are switched off, but we can make a list of multiple images. So if we get that one and paste in another one, so Control C to copy, Control V to paste. So let's say we'll switch the first pixel on here and the second pixel on here. You can see it displays those first two frames of an animation. And then if you keep copying and pasting, you have to be careful with the syntax here. Make sure you start the list and end the list, and every image has a comma afterwards to separate them. So this has now got 3 images inside. Let's move the pixel that's onto the next space. At this point it's going pretty slowly, so I'd like to speed up the animation. So if you are a gamer, you'll know what people are talking about when they say FPS. It just means frames per second. The more FPS, the more frames per second you have, the smoother your gameplay or the faster your animation plays. So by default, I think we have a wait of about 0.4 seconds, 400 milliseconds between each frame. If we want to customize it, let's have a look. Help and tips, help and code samples. Let's have a look at images. And then you can see everything you need to know about creating your own images. And then let's see about the display. Control F, display. Here we go. And yeah, delay equals 400 milliseconds. So we can change that in Python by saying delay equals, and a smaller number will be a faster animation. So if we go for 100 milliseconds, that's 0.1 second. So you can create any animation you like. You can have whichever pixels you like, a little face opening and closing its mouth. I'm going to copy and paste one in that I've done. I don't want you to have to watch the whole thing. It's just continuing what we started, but with the pixel going all the way around the screen. And then if you wanted, you could put that in a loop while true, which means forever. Just keep on repeating that animation. You've got a kind of loading, buffering animation. So an animation is just a picture, and a picture is made up of pixels, and the animation just shows one picture after another picture with a little delay in between each one. So we're going to turn that into a bit more of a program. First of all, let's display a random image. So let's choose, help, my alarm's going off. Let's choose some random images. Image.happy and image.sad. So these are built into the microbit library. And then we want to choose one of these at random. So we can say display.show and then random.choice. And as a parameter for choice, we can give it this list here, and this list is called images. So we want to choose one at random from images. Now it displayed it, but we couldn't see it there because it displayed it so quickly that it then went on to, in its sequence, it went on to displaying the animation afterwards. So we have to slow it down afterwards. Let's say sleep for a second, 1,000 milliseconds. We choose a random image and we move on. It would be nice now if instead of just waiting for a certain amount of time, it waited until we pressed a button. So we're going to say while button A dot is pressed, and then wait for a fraction of a second, which doesn't seem to work because you're not pressing the button at the start. So we'll say while we're not pressing that button. Okay, so we have our random image. When we press the button here, we're no longer not pressing the button, double negative there, so we wait until we are pressing the button, and then it chooses a different random image. Always seems to be sad at the moment. Let's see if we ever get a happy image. No, always sad. There we go, we get a happy image. So your challenges, I'll copy and paste them across so that you don't have to see me writing these out. You can try and speed up and slow down the animation. So changing the delay between each frame will make it slower or faster. You can experiment with different random images. So instead of just happy and sad and I've got asleep in here, you can see all sorts of different ones in here that you can try out. And then you can create your own animation. So a boat sinking or a happy face turning to sad. Just change the pixel coordinates, trial and error, and you'll see what you can come up with. So remember, the links to all of the activities related to this challenge are on live.withcode.uk. The winner from this week's competition, if you're registered for part of the competition, which is free to do, the winner will receive a microbit this week. So do get your scores submitted as you work through the challenges. Thank you ever so much. Enjoy half term, and I'll see you next week. Bye bye.